For this chemical equation, we have calcium phosphate reacting with silicon dioxide and carbon to produce calcium silicate, carbon monoxide, and phosphorus. What's special about this chemical equation is that the polyatomic ion, which is phosphate, is only found in the reactant side, but it's not found in the product side. So therefore, what I'm going to do, I'm going to break down this polyatomic ion into phosphorus and oxygen. So let's find out how many atoms we have to get started. So we have 3 atoms for calcium. For phosphorus, we have 2. For oxygen, we have 4 times 2 is 8, plus 2 more from here is 10. For silicon, we have 1 of them, and then we have 1 for carbon. On the product side, we have 1 atom of calcium, 1 for phosphorus. For oxygen, we have 3 plus 1 gives us 4. For silicon, we have 1. For carbon, we have 1. Next, we need to identify the loner, also known as a pure element. That is the one that is not part of a compound. So the only ones that are not part of our compound are carbon and phosphorus. The next thing we need to do is identify the 1:1 ratio, also known as the pair element, and that is the element that appears one time in the reactant side and one time in the product side. And it doesn't matter if the subscripts are different, and they can be part of a compound. So calcium, it appears one time in the reactant side and one time in the product side. Phosphorus, it appears one time in the reactant side and one time in the product side. Oxygen, it appears 1 and 2 times in the reactant side and then 2 times in the product side. So I'm not going to put a check mark. Silicon, it appears 1 and 1. Oxygen, we already talked about it. Carbon, it appears only 1 time in both sides. The next thing that we're going to do is that we're going to start with the largest 1:1 ratio, also known as the pair element. And this is the element that has the largest subscript. So out of the ones that I put the check mark, the one with the largest subscript is going to be calcium. So I have 3 calciums in the reactant side. So I need to have 3 calciums in the product side. But before I can even mess with this, I'm going to lock in this compound of calcium phosphate with a 1. So 1 times 3 gives me 3. So I need 3 over here in the product side. So now we have our calciums that are balanced. Now the question is, where do we start? Do we start with calcium phosphate or do we start with calcium silicate? Meaning, do I continue the process with calcium phosphate or do I continue the process with calcium silicate? And the answer to that is by answering the following question. Which of the 2 compounds produces the biggest change after adding the coefficient? And of course, the answer to that is calcium silicate. Because over here with the calcium phosphate, by locking it at with a number of 1, everything remains the same. However, over here, things start changing. For example, we now have 3 silicons instead of having 1 of them. So if I have 3 silicons in the product side, I need to have 3 in the reactant side. So the next question is, can I continue with this compound? And the answer to that is no, because we have made a change in here. We have also closed in some elements where we now know how many total atoms we have. So, for example, notice that we added a 3 And when we added this 3, we locked in this compound. When we added this 1, we locked in this compound as well. So therefore, it means that my oxygens are complete. So I need to find out how many I have. So I have 4 times 2 plus 3 times 2. 4 times 2 gives me 8. And 3 times 2 gives me 6. And 8 plus 6 gives me 14. So I now have 14 of them. Now I can come to the product side again. So I know I need a total of 14. But we need to find out how many we have first. So we have 3 times 3 gives me 9. So therefore 9 plus what number will give me the magic number of 14. So of course 9 plus 5 gives me 14. So I'm going to come over here and I'm going to put a 5 in the coefficient. And now my oxygens are balanced from both sides. So our calciums are balanced and our oxygens are also balanced. And notice that we have the loners last, and that's usually what you want to end up with last. By the way, our silicons are balanced as well. So at this point, do we have any other elements that have closed out? Of course. Phosphorus has closed out with 2 because 2 times 1 gives me 2. So therefore, I need 2 over here. So I'm going to come here and I'm going to write a coefficient of 2. So my phosphorus is close. They are both close on both sides. Now, I know I have 5 carbons. And then I can come over here to the reactant side and write a coefficient of 5. And at this point, everything is balanced. 1, 3, 5, 3, 5, and 2.